Hello, everyone. You are tuned into today's PIR live event with Dr. Alex Ferworn, Professor of Computer Science and leader of the Network-Centric Applied Research Team, or NCART, at Ryerson University. My name is Anne, and today Dr. Ferworn will tell us about his exciting research with rescue dogs and robots that aims to save lives and improve rescue times and outcomes in disaster situations. Sounds like very cool research. But before we get started, I'd like to welcome all of our viewers on the live stream. It's great to have you all with us today. For those watching the live stream, remember that you can tweet your questions using hashtag AskPIR to us throughout the live event. And if there's room, include your name or your city so that I can give you a shout out as well. I look forward to getting to some of those questions in just a moment. But first, I'll turn it over to Dr. Ferworn. Thank you so much for joining us today.
Well, thank you, Anne. I guess I should start by saying a bit about what we do. So the research area is somewhat new for computer science. We call it computational public safety. We tend to focus on disasters or urban disasters. So it's not hard to imagine an urban disaster. Essentially, that's a bunch of buildings falling down all at once. A normal emergency is when the local firefighters and police and medical staff can deal with that situation. But it becomes a disaster when it's beyond their capability to do that, and that's when we start to get interested. And so what these emergency organizations do is called response. They respond to this emergency, which becomes a disaster, and they try and save people. And what we do is we develop technology that tries to help them find people faster within the rubble of such a disaster. So that's what we do. And we tend to do it with dogs.
Yeah, which is awesome. So one of the technologies you use, I see, is called Canine Augmentation technology. Maybe you could tell us a bit more about that and how the rescue dogs and robots work together?
I guess a few years ago, maybe 5-6 years ago, we had this strange notion that we could make walking robots. And I'm not that great a roboticist. When I tried, it turned out that's a harder problem than I first thought. So I got together with a bunch of my students, and they realized, hey, you know, the easiest thing to make is something that we didn't have to make. We thought something that already walks, and that's a dog. None of us had a dog, so we started looking around for dogs. So the first person, took about 6 months, and the first person who had a viable dog, meaning not the crazy dogs that jump all over you, but a dog is calm and able to do something for you, like carry a camera, was this Ontario Provincial Police dog called Dare. And Dare was such a calm dog, and he had a special skill that we didn't even know about. And his special skill was he could find people buried in rubble through smelling them, and he could do it accurately every single time. And when he found somebody, he would bark. So we thought, well, some of the problems that the police that follow this dog, they sometimes couldn't go into the rubble where the dog could go, because if you've seen dogs run around, they're really good at it, and we're not anywhere near as fast or as agile as they can be. So the dog would run into the rubble, and the cop couldn't follow, and the dog would start to bark, meaning he found somebody, and the cop would think, oh, well, that's great, he found somebody, but I have no idea where they are. So our response to their response problem was to create a camera for the dog, and that was known as CAT, ironically, Canine Augmentation technology. So we put twin cameras on the sides of the dog, and we let them film what the dog actually sees. So that was our first attempt. We've been working ever since to sort of expand the effort. Now we have technologies that let the dog drop things off from the dog itself. So if you want to carry a radio with the dog, since the dog barks, we pick up that barking, and we let the dog control dropping off a radio to whatever victim they happen to find, so that hopefully we can establish communication with somebody that's buried under the rubble. So we sort of follow along those lines with all the things that we do. So we don't help the dog at all. Actually, the dog's really good at what they do. We just sort of help the people who are trying to understand what the dog is experiencing.
Yeah, that's awesome. So the dogs can deploy a radio, but I understand they can also deploy maybe robots with cameras to let me just see if I can actually find one that's here on the left. Hey, do we have Dex lying around somewhere? We have a small robot that we actually attach underneath the dog. So while one of my grad students is looking for an actual robot, we have this
fake dog, which I bring into the scene. And so the idea is, dog doesn't have a lot of real estate to deal with. This one's kind of a fake Labrador Retriever. What we do is we have this type of robot. So this is a robot we made in the lab. It's been 3D printed, so it's got its battery packs on the side. And if you look carefully at the front, it's got a little camera. And what happens is we have a little bag, strangely called the Underdog, since it fits under the dog. And the dog will actually carry that into a rubble pile. And when it barks, the robot will fall off. The dog will run away, or not fall off the table. And then this robot will stay with the victim. So we have sort of a two-way connection with the person. Now, this is actually really important because now imagine yourself caught in rubble. So, oh man, building falls down on top of you, and you're lucky enough to survive. So you survive, and then you're alone. So maybe it's a day later when they finally come and find you, and the first thing you see that actually is a friendly face is the dog. And it barks a lot, and then it unfortunately has to go away. So when it goes away, you're alone again. So how do you feel? So at least if the dog can leave a robot, the robot might have a light on it, and you can talk to the robot and they can hear you and may be able to talk back through a speaker, you realize somebody's coming for you. And that would be a benefit to whoever happens to be trapped. Right? So, so there you go. That's the idea.
Very reassuring. Does the robot do anything else while it's with the victim? Like, other than maybe establish where the victim is and their surroundings? Does it do
We've tried several different types of robots that could potentially be dropped off. I said Dex is our homegrown version. We have a snake robot. We combined efforts with a lab in Carnegie Mellon University in the United States where they develop snake robots. And the problem, so actually the benefit of the snake is it's very flexible. So when it gets dropped off from the dog, it's able to wriggle around, and it might be able to go closer to the victim than our dog is able to, or than our robot is able to. Now, the problem with the snake is it's got a lot of motors on it, and it takes a lot of energy to run that, so it's tethered. Now, imagine this. You have this free-running dog that now has to drag in this snake with this giant tether in the back end, so that the robot itself is not without weight. It weighed about 7 or 8 pounds. So we got this giant German Shepherd called Freitag who could care less about this robot, and it dragged the snake and the tether in about 50 meters into a tunnel system and dropped it off, and didn't appear to even notice that it was carrying anything at all. So that snake wriggled around and was able to go underneath the victim and actually send back video about the situation of what's underneath the victim as well, which can be very important as well. So there you go. So it's kind of up to your imagination what you could drop off. So we, as I said, we made a small robot to show that it was possible, and we demonstrated in Texas and Ohio. Now it's up to somebody else to actually make more of them and more useful robots. So there you go.
Yeah, so that sort of touches on one of the considerations when you're designing a robot for this purpose. Having it use up a lot of energy and having to be tethered. What other sorts of considerations are there when, you're trying to design a robot that will fit on a dog and be able to maneuver in rubble?
Well, there's a coin, or a term we coined called dog-ergonomics. Have you heard of ergonomics? It's sort of making things for people that are comfortable. Well, a dog will tell you quite quickly when it's uncomfortable with something. So there's obviously a weight limit on what a dog can carry. So we say usually it's below the 10-pound mark, probably less than 5 pounds, and it has to have a certain size. So it has to conform to the dog's shape. And dogs come in various shapes. So we discovered in this research that there is no standardized mechanism for measuring a dog. Everybody seems to have all kinds of dog lore, but very few numbers that actually go with that. So we were working with a professor in fashion in computer science. We don't do fashion, but we have fashion here at the university. And she undertook the idea of creating canine apparel. So we created a series of dog bras, and unfortunately the canine handlers tend to be male, and they have the sort of male attributes. Like they don't like this notion of bras being on their dogs. So we had to change the terminology, but really we were putting bras on dogs, and they worked really well. So the robot kind of has to conform to the dog, and the apparel or the harnesses have to allow you to put the robots on the dog in that way. Now, there's other issues as well. I mean, rubble is an unsafe environment, right? So if you ever see a construction site or a destruction site, so say when they pull down a building near your area, they do it with giant cranes and backhoes and shovels. And the things that are exposed tend to be iron bars and concrete blocks. Now, those iron bars are called rebar, and they're extremely dangerous. And one of the things we were working with first responders, emergency first responders, and canine handlers for was assuring them that the dog won't get stuck. Because if you think about it, if the dog runs in there with an article of canine apparel, clothing, and that dog gets stuck, you've just lost the dog. The dog, you can't rescue the dog because you can't follow the dog. So we developed various schemes of getting the apparel to fall off, so the harnesses will be magnetically linked or attached by Velcro, so that if the dog got stuck, at least the equipment would be left behind and the dog could escape. So eventually we got a certain amount of confidence in the canine handlers that we were working with, and they just let us put just about anything on a dog as long as the dog could actually carry it. They seem to have forgotten all about the safety issues for the dog, but we continue to worry about that. So we're working now with a real professional canine apparel manufacturer who is designing a special harness that won't get stuck on anything and give us a lot more ability to mount our cameras and other sensors on the dog. So there you go.
Yeah, very cool. We have our first question from Twitter. Christine and her homeschool group want to know, they've noticed the green suit behind you, and they want to know what the big green robot behind you is.
That is actually a bomb suit. Let me put it closer. I don't know how this works exactly. I'll point to various parts of it. So you see this part here is the helmet, and that's a visor that you see normally would be there. So what happens is the specialty team we work with in the Ontario Provincial Police, they have two lines of specialization. One of them is urban search and rescue, what I just talked to you about, and the other one is called CBRNE, which probably you've never heard of, but it's chemical, biological, radiological, and nuclear explosive team. And what they do is they worry about the nasty stuff that could explode and harm people, and they definitely try not to get injured themselves. And one way to avoid getting injured when you're dealing with an explosive device situation is to wear protective equipment. Now, the bomb suit actually is lined with Kevlar, hard plastics, various things that are not likely to allow your injury. So it takes the blow for you if there's a bomb. Not to say that it would be a pleasant experience, because it would not, but at least you have a better chance of survival. Now, the reason we have the bomb suit is we want to mount sensors on the head of the bomb suit. Like if you look, it's very clumsy, right? So if you look at this thing, it's heavy, it's annoying. In fact, I punish my graduate students by making them wear it around the place. So what we want to do is avoid the fine manipulation that you would normally have happen with a bomb suit. Now, one of the things that a bomb tech would have to do is move close to the device. And the way you disarm a bomb is a strange thing. You actually, you hopefully try and remove it completely from where it is, but if you can't remove it from where it is, you try and identify where the power supply is on the bomb, because inevitably it's electrical. And so you kind of shoot a bolt of water at the power supply, hoping to knock it off. Now, like anything, we actually have a gun that mounts on a robot. We actually have such a robot. I don't know if I can actually show it to you. So, see sort of the gray box on top. That's sort of the top of this actually mounts something like a shotgun. Now, if anybody's ever shot a shotgun, you realize you got to aim that thing pretty closely. Well, of course, now you've got the shotgun mounted on a robot, and the robot has no idea how to aim. So what you do is you put a cop in one of these bomb suits, and you send him downrange, they call it, and he has to set up the robot and the shotgun and doesn't touch the bomb. It has to have exact measurements because you can only fire from a certain range. So what we're hoping is that by mounting sort of a three-dimensional sensor on the head of the bomb suit, the bomb tech can then just walk around the bomb scene, and we can build a three-dimensional model of what it is and give them exact measurements. So instead of taking out your Canadian Tire scale of measure, your tape measure, we can just give you an exact distance based on a model that you can hopefully see in the visor of your bomb suit. And so they do this, they set up the shot, and then they fire at it. And if all goes well, the bomb is neutralized and all people are safe. And our technology hopefully will work. Have we ever done this? No. But it is cool watching stuff explode.
Yeah. That's awesome. So have your robots ever been used in a real disaster situation, or are you still testing those as well?
We're testing them. They were almost one of the devices we had was almost deployed to in 2010. There was an earthquake in Haiti, and the team we worked with was scheduled to be deployed with Toronto Heavy Urban Search and Rescue. So they were going to go to Haiti, and my grad students were busily working on the prototype and turn it into a more ruggedized version so that the team could actually take it with them. But the Canadian response turned out to be just money, so the federal government sent Disaster Assistance Response Team, or DART, from the Canadian Forces and a whole bunch of cash, and they never deployed any civilian first responders, so it never went. But we've been on various exercises. In fact, I talked to you a little bit. We're going on an exercise on the 25th of this month to Windsor. So the OPP have requested that we bring our technology with us so that their Canine teams can use it. So we'll do a bunch of modeling for them and hopefully find some people in rubble. So we know it works. Actually, it's one of those things where you'd like to see it work in reality, but you kind of don't want to see it work in reality because, you know, if it's deployed, it's bad, right? So we're kind of happy to be in the lab at the moment.
Yeah. I have a question going back to the robots again. You mentioned the materials that the bomb suit's made out of. What kinds of materials are the robots made out of?
I can actually show it to you. Chris, can you bring over some printing material, a 3D printer spool? Just give me one of those. Yeah, give me some of that stuff. And one of the raw material as well. Sure. Yeah, he's coming over with it. Yeah, you'd be surprised. Do you think this stuff is really high technology? Yeah, so we'll show you some of the things we can print. Assuming he's like, you better toss me some of those things. Here, just toss me one of the printed ones. Yeah, okay, so I'll show you what can be done. So here, this is actually a set of, here. So this is like a sort of a test blank. So what this is kind of a ball bearing system that we made, and a bunch of gears, here, a bunch of toys that kind of spin. But the real trick is we can actually do three-dimensional models of, oh yeah, here's a, we don't actually know what this is, but it's kind of cool. But this is rubble. So this is actually rubble that we modeled in Texas. It was a weird kind of rubble pile because this is actually a couch you can see on top, and this is a culvert where the dogs would actually enter in for our searching. So we made a three-dimensional model of that, and they're saying, well, what is this made out of? Like, and a robot is made out of the same stuff. So Dex, that I showed you before, is made out of the same stuff as this, and this stuff is essentially whippersnipper. Like if you have a whippersnipper at home, it's not exactly the same plastic, but essentially it's a spool of plastic, and the 3D printer will take that and melt it over time and inject it into exact spots. It's not exactly as perfect as having it manufactured. So this robot, if it was manufactured out of pure plastic bits, might be waterproof, but ours tend to be not waterproof because there's little dabs of plastic that are ejected, so that leaves little holes. So the plastic that we inject tends to get waterlogged, we discovered. So there won't be any boats that we make out of our 3D printer. They tend to sink. But as a prototyping material, it's quite useful. So the plastic's really cheap. We have thousands of well, no, I wouldn't say thousands. We have dozens of rolls of the stuff hanging around the lab in various colors. And of course, just like Big Bang Theory, we have our bobbleheads lying around here somewhere as well. So there you go.
That's really cool. So all the robots you've been working with so far have been 3D printed?
No, our first robots were made out of junk. I wish I could see one that was just lying around. Do we have a junk robot? Give me one of those robots over there. Yeah, to the right. Yeah, that's anyone. Anyone will do. One that you can lift that probably won't fall apart. These tend to be kind of fragile. So our first robots we were actually teaching an undergraduate course. So if you came to Ryerson, you'd be building crap like this. So this is actually a sumo robot there's its brain on top, actually wired by I guess it was a third-year student, and there's its power supply and motor system, and it's got like golf pegs for weapons, and it sees you with these eyes. And it's made essentially out of wood, medium density fiberboard. Over here? That's a wooden wheel. These are bits of aluminum. Basically, we found it. Most of the stuff is found. Students at Ryerson who take these courses, they tend to carry around a shoebox full of junk, and that junk slowly becomes a robot. And what we try and teach them is not so much what to do with the junk. They kind of figure that out for themselves, but we give them a notion of what you can do. So the course is called Autonomous Mobile Systems, meaning we want to get the robot to do as much as it can alone without investing too much time, effort, or computation. So this changes the way students tend to think, and it helps us in the lab. So when they go from this monstrosity I just showed you to eventually making decks. So the student that made this thing was instrumental in making this thing, just because of the way they think. So that was sort of our philosophy of how we try and get students to think. Plus, we're cheap. We don't have a lot of cash, so this is a great way of working.
Yeah, that's really cool. We have another question here, this one from Drew. He wants to know, can the robots and dogs be used for things other than finding people in rubble? For example, could the dog drop off a robot that could be used to analyze the state of the rubble so that it doesn't collapse further when rescuing people?
Yeah, actually, I can give you a search term you can look for on YouTube. We've tried this as well. Not so much dropping off a robot. Like a robot is only one way of looking at the world. So one way of one problem that first responders tend to have is there's no reliable communications in these rubble piles. So if you search on YouTube and you look for Canes, Canes, Ryerson, and Ferworn, so Ferworn, you will probably find a video that shows you us dropping off repeaters, or they're essentially Wi-Fi routers that get dropped off from the robot. So they're not looking for anything. What they're actually doing is producing a radio signal. Now, if you have enough dogs drop off enough of these repeaters, they form something called a mesh network. So they mesh themselves together, and they know how to communicate with each other despite the fact that they don't move. And the beauty of this is it actually sets up a line of communication underneath rubble rather than just over top of rubble. So when, say, firefighters are looking for you, if the dog manages to drop one of these things close to you, you should be able to actually tie onto it with something like your smartphone. And if you're using your smartphone, we hopefully will be able to find you using that signal. So there are lots of ways we're continuing to experiment with this notion of finding people under rubble using only things that they have on them. And the dog would be instrumental in dropping off something like that. So it wouldn't be a robot that's dropping off. It would be dropping off this mesh router. So yeah, we do it for many things. As I said, we also work for these CBRNE scary guys with bombs, or trying to remove bombs. They have lots of uses for dogs that have nothing to do with finding you in rubble. If you've been in the airport, you'll see that dogs are sniffing at you. They have search dogs. They're looking for drugs mostly, But some of those dogs are actually bomb dogs, meaning they will look for accelerants and explosives that you're also not allowed to have on you. And those dogs actually sit. So where an USAR dog, the rebel dog, will bark, these ones actually sit and look directly at a device. Well, this is cool because since the dog stops, we have a much more stable platform. So we'd like to do many things. So we have other sensors that we would like to mount on the dog that's now stationary, so we can sense kind of what's going on with the explosive. Now we have some crazy ideas, right? So there's a sensor called near infrared brain spectroscope. It's a physics sensor, and what it does is it measures the oxygenation and deoxygenation in your brain. So it actually sends a small infrared signal, light, into your skull, and it measures your capillaries expanding and contracting depending on how much oxygen is actually reaching your brain. And there is a certain correlation between what that does and what you're thinking. So if you've seen those things on functional magnetic resonance imagery, fMRI, this is sort of a different type of the same kind of sensing. So what we want to do is actually attach these things onto dogs. So we actually have another dog bra. It goes over the dog's head with this near-infrared brain spectroscope attached to it. And we did some tests with bomb dogs to see, because we have this idea that not only can the dog detect the explosive, but we believe the actual dog might actually know what the explosive is, but it can't tell you because all a dog can say is "roof." So we think that we might be able to actually, in a sense, kind of read what the dog is thinking in a broad way. So this is another use for dogs that we have that have nothing to do with dropping anything off, but with sensing from the dog. Right? So I don't know if I answered your question, but I do tend to ramble, right? So.
Yeah, no, that's so cool. And thanks, Drew, for that question as well. We have another question from Christine. She's wondering, what was the biggest robot you've made?
We tend to make very small robots, mostly because of the size constraints and the money. The bigger you make them, the more difficult they are to maintain because they just require more and larger items like motors and different actuators. They become prohibitive. So what we tend to use is we tend to reuse things. So we have a bunch of wheelchairs that we used. We had a project once called the Network Enabled Power Wheelchair Adapter Kit, NEPWAC. So it actually became quite an elaborate thing because it had a set of cameras on a traditional wheelchair, electric wheelchair. And the idea was that we would actually have a sort of a web service on the wheelchair that allowed you to connect to a wheelchair and drive it around. Because we thought, since we have an aging population, we thought it might be cool to have sort of services available on the wheelchair for somebody who might be stuck in it, who can maybe talk to a doctor or a nurse somewhere remote. We thought this would be the greatest thing since sliced bread. So that was the largest robot we ever worked with, which is slightly larger than a wheelchair you could imagine. And people hated it. The reason people hated it, I think, is because people don't like the idea of being in a wheelchair with good reason. They also don't like people watching you in a wheelchair, and they certainly don't like the idea of someone taking control of that wheelchair. So we were pretty much banned from a building of old people because we suggested this idea. So we stopped that line of research.
Okay.
So that was the biggest one.
Yeah, thanks for that question, Christine. We have a couple minutes left. Maybe to finish off the session, you could, talk about if somebody wanted to do your type of work, working with robots or in disaster situations or both. What kind of advice do you have for them? What can they do to get there?
There's a number of ways you can enter this field. So the people who are responsible for dealing with urban disasters are essentially first response organizations. So this is mostly firefighters and police. If you're interested in working in terms of technology for this, there's a few places you can go. So there's a traditional engineering way of looking at the world. So we have at Ryerson, we have electrical engineering. So I have a colleague who's interested in mine safety. So he's working on systems for transmitting data underground using wireless networks. So this is actually quite an interesting thing. So he's an electrical computer engineer. Here in the NCART lab in computer science, we are more interested on surface disasters. So we're interested in helping first responders. So the type of education you would need would be some background in computer science, because basically all the gadgets we run have either, well, we usually have both mechanical components and computational software that runs on them to make decisions. So a lot of things we do are artificial vision systems, so things that interpret camera data and give us a signal when something happens, so we can make decisions on it. So you would go into something like machine vision or robotics in computer science, so you could work in this area. Lots of places offer it. We tend to be, in Canada, virtually the only place that worries about urban disasters. So we're the lab, basically, and we work with the Ontario Provincial Police and Toronto Heavy Urban Search and Rescue, which had been in the news when the Elliott Lake disaster happened. They are the ones who responded to that. So none of our equipment went with them, but they said they might have been able to use it. But so that's we have probably 8 or 9 students now, graduate students, and 2 or 3 undergraduate students in computer science and medical physics, strangely, because we offer a program here, an undergraduate program called medical physics. Now we tend to try and save people, but people don't like to be prodded that much and buried under rubble. So we're trying to make fake people, so basically devices that have the same temperature and thermal characteristics people, so we can detect them under objects. And so that's a medical area, and a physicist works with us to do that. And these aren't graduate students or anything. These are second-year undergraduate students who are working on this as a project because they never thought that anybody would have a need of it. And we're crazy computer scientists, and we need somebody else who knows about people. So we work quite closely with them. So all told, we have about 15, maybe 16 students spread out through the entire university, kind of worried about this stuff. So Ryerson has about 70, I would say, faculty members who have something to do with public safety. So this would be sort of the area to come, right? So the undergraduate, get yourself a math, science background, and just remain curious, right?
Yeah, that's awesome. So sounds like Ryerson has some really neat programs for students to look into. That's cool.
Yep, we'd like you to come. Yep.
Yeah. So that's all the time we have for today's Q&A with Dr. Ferworn. I'd like to thank all our live stream viewers for watching, and everyone who tweeted in a question today. Thank you. And I'd like to thank, of course, Dr. Ferworn as well for joining us and sharing all his insights and advice. Thank you very much.